So in this video we want to talk about vectors and scalars. So we have a scalar quantity, and that would be anything that has magnitude only. Remember, magnitude just means size. For example, we have distance. Distance just measures how far, and we can measure that in meters, 10 meters. So our distance is 10 meters. All it tells us is the size. Vector quantities, vectors, have magnitude and direction. So they have magnitude and direction. So instead of just distance, we call it displacement, which would have a distance or a magnitude of 10 meters. And we can say maybe it's going up. So a displacement of 10 meters up. The scalars we've talked about have been, we've had time. Right, 3 seconds would be a good time, right, just the size. And we've also had speed. So we have something going 30 miles per hour. Now with our vectors, we had velocity, which we said was just a speed with a direction. So we could take our 30 miles per hour and have it go north. Then we also have acceleration. So we might use that of gravity. Right, it's about 10 meters per second down. So the difference between scalar and vector is really just one word: direction. Vectors have direction, scalars don't. Vectors can be represented graphically, so we can draw a picture of them. This will help us see what's going on with a little bit better. We're going to talk about things going in two different directions at the same time. So for our vectors, we're going to try to draw these out. So I need to use a ruler, and if you don't have a ruler, just use a straight edge and kind of pretend, right, draw out a nice straight line, and then we'll just label it with some distances here. But let's start off by just drawing a line about 2 centimeters long. So draw yourself a nice little 2 centimeter line on your paper there. Alright, so we just want to draw 2 centimeters. And so this 2 centimeters is going to represent the magnitude. Right, the length is going to equal the magnitude of your vector quantity. And we'll talk about which vector quantity we have here in a minute. So for right now, just make sure you have a 2 centimeter line. Pause it if you need to until you're ready to go on to the next part. So next, you want to actually make this a vector, tell you what direction. So we need an arrow on it. So you want to go here to the end. We'll do this on the right end this time, and simply draw the arrow back towards the left. There you go. It's colored in so it's easier to see. So there you go. You have a little arrowhead. So the actual arrowhead represents the direction. So now we have a vector. Alright, now be sure that the length, the entire vector, is the 2 centimeters. And this part of the vector we refer to as the tip, and this part of the vector we refer to as the tail. Now that I have this 2 centimeter vector, I can make it represent any vector quantity I want to. I can make it represent an acceleration, I can make it represent a velocity, I can even make it represent a displacement. Any of these that I want to, any other vectors that we come across, we can do this. We just have to set a scale to identify what this vector actually means. We need to identify what the 2 centimeters means, and we have to identify what the direction it's pointing actually means. So for the idea of a scale, looking at a map of Georgia is a pretty good thing to kind of compare. So we're up here near Atlanta. If we're going to go all the way down to Savannah, we're going to draw a line there and say we look at that and say, oh my goodness, this is a 5-inch line here. And we know Atlanta to Savannah is not 5 inches away. So we look over here on the map, there's a scale. The scale says here that every inch is 50 miles. So if every inch is 50 miles, 5 inches represents, based on the scale, 250 miles. So we can see on here we've taken a value, 5 inches, this distance on the paper, and we're making it represent a larger distance in real life of 250 miles using that scale. We also then have on the maps a compass rose, which gives us our north, south, east, west directions. And so this lets us know which way is which, and so this will use this same idea with our vectors by setting up a scale. So let's make a scale for our vector here so we can represent a displacement. Let's say that 1 centimeter equals 10 meters. So we have 2 centimeter vector, then we're going to have a total of 20 meters being represented. So that's the magnitude, that's the size of our displacement vector here. Next we need a direction, so let's just be simple about it. Up on a map is usually north, so we'll just call this north, like that, so we're not in confusion, which means since we're pointing to the right, this is actually east. Our vector is pointing to the east. So we have a displacement vector of 20 meters to the east. It's a 2 centimeter drawn vector pointing to the right on our paper. Our scale says it's 1 centimeter is 10 meters and up is north. So we have a 20 meter east vector. Now I want to have you draw a vector on your own. I want you to use my scale that I have here, right, the one we just finished up with, and I want you to draw a displacement vector that represents 50 meters to the west. I want you to draw 50 meters to the west. So at this point I want you to pause the video until you've drawn that vector and then unpause it and we'll continue. Welcome back. So you should have a vector that looks like this, should be about 5 centimeters long, well exactly 5 centimeters long, and pointing to the left. Don't forget that the length, the 5 centimeters, needs to go all the way from the tail right here all the way to the tip right here. One of the most common mistakes that's made is measuring a 5 centimeter line to this point and then adding on the arrowhead past that, and that's going to be longer than 5 centimeters. So make sure you've drawn it 5 centimeters long like it's shown here, and if you need to correct that, pause and go ahead and take care of that. So let's do one more here with this. Let's take the same scale and let's do a displacement now that represents 40 meters north. Alright, go ahead and pause, and when you're finished, unpause and we will continue. Okay, so you should have a vector that looks much like this one. Should be 4 centimeters long. Again, from here to here is the 4 centimeters. And it should be pointing up according to our scale where we said north was up. So let's have you do one last one. And this one you're going to have to make your own scale. So make your own scale for this one. It'll be completely different than what I have here. And let's go ahead and draw a vector that represents a displacement of 400 miles south. So you're going to go ahead and pause the video now and draw your vector and unpause when you are finished. So let's look at what I came up with and use the same process, kind of check to make sure yours is correct as well. I wanted to have 400 miles to the south, so in my scale I said 1 centimeter was 50 miles. Since I had 8 centimeters times 50 miles for each centimeter gives me 400 miles. Right, so my length is correct. I have 8 centimeters representing 400 miles. Now I have it going down along this angle here, which looks kind of weird because we typically think north like up here, you know, somebody going up the paper. But look at the scale. The scale says I've got west going up at this angle And so going down this way would be appropriate for south, right? We kind of finished out, we could say south is that way, north is that way, and east is that way. So yeah, that'll work. So you can draw it any way you want to. You can turn your paper around, whatever it is. That way it doesn't change anything. You always have your scale set, and then you know what this represents exactly. That's how you go about drawing the vectors, drawing them graphically, setting them to scale. And so next video is going to go over how to actually use these vectors and combine them in different ways to represent what's going on in terms of our motion that we've been talking about.